All right, this is the second part of the note-taking guide for 6.3 for Math 3, where we're graphing functions. All right, you guys, so if you remember yesterday when I told you how to graph these, the very first thing I said you needed to do was have it in factored form. So you have to factor the top and you have to factor the bottom. So help me factor the top. What are my two numbers that will multiply to 6 and add to 5? 3 and 2. Good. A positive 2 and a positive 3. Okay? And then we're going to factor the bottom. So find me two numbers that will multiply to a negative 10 and add to a negative 3.
5 and 2.
And what's the signs?
-5.
Yep, negative 5 and positive 2. Good. Now I can go and answer my questions that are listed down below. I'm going to find my discontinuities, and if you read right here, it tells you that your discontinuities are when your denominator would equal 0. So what numbers will make your denominator 0? Positive 5 and negative 2. And those would be x equals, right? If x equals 5, I have a problem. And if x equals negative 2, I have a problem. Now to decide whether or not those discontinuities are wholes or vertical asymptotes, I'm going to look to see if any of them cancel. Do any of them cancel?
Yes.
Yeah, what cancels?
X plus 2.
The x plus 2. When that x plus 2 cancels, it automatically makes it a whole. So I have a whole at x equals negative 2. Once it's a whole, it doesn't get to be anything else, you guys. So it's a whole or nothing at all, okay?
Why would it be negative 2 and those are both positive 2?
That's a good question. Why is it negative 2? Because what's the value that makes this 0? The value that makes it 0 would be a negative 2. Okay, and negative 2 plus 2 makes 0. 0 is when I have a problem on the bottom of my fraction. Okay, because I can't divide by 0. Okay, vertical asymptotes then. Again, we look at our discontinuities. My discontinuities are either wholes or they're vertical asymptotes. If x equals negative 2 was the whole, what's my vertical asymptote? X equals 5, right? So that tells me at 5, on my x-axis, I have an asymptote. You guys following me on that? Okay, the next question says, where are my x-intercepts at? Now, x-intercepts come from where the top would be 0. But remember, once this becomes a whole, I don't have to use it anywhere else. So where's the only spot on the top that I'd have to worry about for an intercept?
Negative 3.
Negative 3. So x equals negative 3. That means that my graph is touching or crossing the x-axis at negative 3. So right here. Okay? Then one more thing that we need to find. We need to find our horizontal asymptotes. Now that comes from the rule that I gave you the cheat sheet for. I'm going to look at my powers on my numerator and denominator. What's my power up here? 2. My power down here? 2. When your powers are the same, the rule says take the ratio of the leading coefficients. So what's out in front here? What's out in front here? And what's 1 over 1? So it's horizontal, so it's going to be y equals 1. So draw your horizontal asymptote at y equals 1, and then we're going to see if we can figure out where our graph's at. Did this x-intercept help us know which quadrants we were in? Yeah. I know I have a curve coming like this somewhere, right? And we're kind of just sketching today, so we're not being super perfect. But I know I have something over here. Do you think I probably am up over here then? Yeah, but if I'm not sure, how could I tell? I'm going to pick a point and I'm going to plug it in real fast. So if this is at 5, could I just put in 6 and see if I'm up tall or down low down here? So let's put in 6 and see what happens. I would have 6 plus 2, which is 8, times 6 plus 3, which is 9. On the bottom, I would have 6 minus 5, which is 1, and 6 plus 2, which is 8. Those were all positive, which tells me I'm positive, right? So I'm over here and I'm up here for the other spot on my graph. Okay. Questions on how I did that? Okay, am I done? What did I forget to do, or what have I not done yet on this graph? I have not taken care of my hole. I have a hole in my graph at x equals -2. So I'm going to go to x equals -2, which is right here, and I'm going to draw a hole in my graph there, which is really just an open circle. If I was going to be in pencil, I would erase that little mark in there so it looked like a hole in my graph right there. But I do have a literal hole in my graph at -2. Does that make sense to everybody? All right, let's try another one. Who remembers my very first step? What do? Factor. So what do you get on the bottom?
X plus 5, x minus 5.
Exactly, x plus 5, x minus 5, because this is the difference of squares. Does the top factor or do anything? Nope. Okay. So I'm ready to look at my points of discontinuity. Where would my denominator be equal to 0? X equals -5 and x equals +5, right? If I put -5 in right here, I'd get 0. If I put +5 in right here, I'd get 0. So my points of discontinuity are -5 and +5. Those points are either holes or vertical asymptotes. So I'm going to look and I'm going to see if anything canceled. Because if it cancels, it's a hole. If it doesn't cancel, it's an asymptote. So does it cancel? No. Nope. So holes, there are none. Okay, we're going to use empty set. Okay, vertical asymptotes then. If it wasn't a hole, guess what it is? It's a vertical asymptote. So how many of them do I have? 2 of them. So I'm over at 5. And I'm over at -5. 2 asymptotes right there. Go ahead.
What if both of them cancel? Like the top and the problem are like the same thing, so they both cancel all the way.
Yeah, then if it canceled like that, it would not be a graph that looks like this. It would be linear, because you'd get like y equals 1. Right? If everything canceled. So then that would be awesome, and you wouldn't have to do any of these rules. Okay.
1.
All right. On the x-intercept, that's where we set the top equal to 0. So x equals 0. And then the horizontal asymptotes comes from looking at my powers. The power on the top is 1. The power on the bottom is 2. The rule says if the power on the bottom is bigger, then you automatically have an asymptote at y equals 0. That's the rule. So y equals 0 is right here. I have an x-intercept at x equals 0, which is right here. And then I'm like, I don't know what this graph looks like. So guess what I would do normally? I would pick some ordered pairs, plug them in, and get a good idea where my graph is at. But I'm also going to allow you to grab the graphing calculators out of the closet. So can I show you what this graph looks like now on the graphing calculator?
Right.
In just a minute, you can grab one and try it on your own. So you do y equals. Does anybody know how to graph on the graphing calculator? Is everybody pretty familiar with it? Okay. So I'm going to do x on top. And I'm going to do divided by x squared minus 25. Now when I do my bottom, you guys, I definitely want to put it in parentheses, because I want my calculator to know all of that is on the bottom, okay? Then I'm going to hit graph. And look what my graph looks like. It's kind of funky. So when you graph these on your graphing calculator, they're not like super exact in the fact that this really goes up forever and comes over forever. And then this one really goes over and comes down forever. And this one is kind of like a swoop. Kind of like a cubic graph right there going on there. So our graph actually looks like this if we come back over and graph it. We're here like this. We're down here like this. And we're through the middle kind of flat like this. Okay? And I'm totally okay with you using graphing calculators today, as long as you find this information for me first. Does that sound fair? Yeah. Okay. Last one to do on our own before we do our worksheet, okay? The very first thing is to factor top and bottom. Neither the top or the bottom factor, so I can't do anything. So I have to find my discontinuities by setting the denominator equal to 0. So I have x squared minus 3. I'm going to set that equal to 0 and solve. How do I solve that? I isolate the variable by adding 3. How do I get rid of the squared? Square root. Okay, so every time I square root, I get plus or minus, right? So I have plus or minus the square root of 3. I'm going to change that to a decimal point number because I don't want you guys to wonder where the square root of 3 is at on your graph. It's actually 1.73. So I'm at 1.73 and I'm at negative 1.73 for my asymptotes. Okay? And I know they're asymptotes because did they cancel with anything on the top? No, so they're not wholes. So they're automatically asymptotes because they weren't wholes and they were points of discontinuity. So almost over at 2 and then almost over at negative 2 are my two asymptotes. Alright, x-intercepts, that's where your top part would be equal to 0. What number makes the top 0? 0. So x equals 0 is my x-intercept, which is right here. And then I'm going to find my horizontal asymptote. My horizontal asymptote comes from looking at the degrees, the power on the top and the power on the bottom. What's the power on the top? 2. The power on the bottom is 2. So that rule says use the leading coefficients. So 1 over 1, which is 1. So I have an asymptote at y equals 1. Now I know I'm right here, which means I probably is kind of like an upside down parabola right there. But once you get to that point, you guys, I'm totally okay with you punching it in your calculator and seeing what it really looks like, okay? So over here on the calculator, on the top, sometimes I like to put my parentheses because I don't want my calculator to be confused with that if it's x or the squared part or whatever it's doing. So I like to put extra parentheses just to be careful. On the bottom, I'm going to have x squared minus 3. Do you guys think it matters if I put it in, say on this other problem where I had it factored over here? Is it okay if I put it in as the original or if I put it in factored form? It's not going to matter. It will do it for you both ways, okay? All right, when we graph that, you guys tell me how our stuff looks. Are we like where we're supposed to be? Yeah. So you know on this graph right here that you have a curve coming down like this. You have a curve coming up like this. And you're going to be bound in this little area right here for our last part of our graph. So again, you guys, today what I expect is that you get this information for me. Use a graphing calculator to sketch the graph, okay?